So for this problem, we're going to look at the integral of tan squared x minus 1 with respect to x, the integral of cot squared 3x with respect to x, and the integral of cos cubed x with respect to x. In order to solve each of these, we're going to need to use some of our other trigonometric identities from an earlier identity, sine squared x plus cos squared x, which is identical to 1. You're able to derive tan squared x plus 1 is identical to sec squared x, and 1 plus cot squared x is identical to cosec squared x. And a couple of other integrals that we're going to need for this. The integral of sec squared x is tan x plus c, and the integral of cosec squared x is equal to minus cot x plus c. So for the integral of tan squared x minus 1, well, we don't like the tan squared, so we're going to replace that using our identity. Tan squared x plus 1 is identical to sec squared. So we can replace the tan squared x with a sec squared x minus 1 minus the other one, which we're then going to integrate with respect to x. A little bit of a simplification then. So we're integrating sec squared x minus 2 with respect to x. So the integral of sec squared x is tan x. The integral of minus 2 with respect to x is minus 2x. And we can't forget our constant of integration plus c. So that's the first one. For part B, cot squared 3x. So again, we're going to use one of our identities. We can replace cot squared x with cosec squared x minus 1, but because this is cot squared 3x, we're really going to replace this with cosec squared of 3x minus 1, which we're going to integrate with respect to x. The integral of cosec squared is going to be minus cot. So in this case, it is minus cot of 3x. But you can't forget that we're also going to need to divide by the derivative of the 3x. So we're going to need to divide by 3. The integral of the minus 1 with respect to x is just minus x. And then our constant of integration at the end plus c. And then part C, the integral of cos cubed x with respect to x, we're going to have to do a little bit more work for. So to start with, we're going to need to break this into two parts. This cos cubed x we're going to replace with a cos squared x times a cos x. We can then replace the cos squared x with one of our identities, or slightly rearrange the very top one, and we can replace cos squared x with 1 minus sine squared x. So let's do that. Well, we don't like these brackets, so let's expand this. So really we've got the integral of cos x minus sine squared x cos x. Now in this form, we can break this up into two integrals. So really, we are integrating cos x with respect to x minus the integral of sine squared x cos x with respect to x. Now, for that second integral, we need to do a bit more work. Well, we know a few different techniques that will work for this, but one of them that we can use is substitution. So for this substitution, we are going to use u is equal to sine x. Now, whenever we use integration by substitution, we need to be able to differentiate our expression. So we need to get an expression for du by dx. Well, the differential of sine x is cos x, and therefore I can say that du is equal to cos x dx. So let's substitute them. we've got the integral of cos x dx minus the integral of, well, the sine squared x I can replace with a u squared, and the cos x dx I can replace with du. And then we can use our usual integration rules. The integral of cos is sine x minus the integral of u squared with respect to u cubed over 3, plus our constant of integration. And the very final stage, which you can't forget, is we need to replace our u with our expression for u, which is sine x. So really, this is sine x minus sine cubed x over 3, all plus c. And that's our final expression for the integral of cos cubed x.